Hi everyone. Now we continue to the final part of module, Example Technology Stack for Order Fulfillment Management module. Before we dive into examples of technology stacks, let's watch the video, What is a Tech Stack, together.
If you're learning to code, it means you probably have a billion-dollar startup idea in your head. But before you can execute that idea, you'll need to choose a tech stack. And you better choose wisely, because it's a real pain in the ass if you decide to change it later. Every app is actually just a technology sandwich, and in today's video, I will teach you how to make a sandwich. We'll look at popular stacks like LAMP, Mean, MERN, Maven, Fluff, Refi, Fart, Fancy, and so on. Then we'll architect our own tech stack from scratch and look at the decision-making process for each layer in the stack. By the end of this video, you'll know how to over-engineer a website like a true professional. If you're new here, like and subscribe, and let me know what kind of tech stack you're using in the comments. The OG tech stack is LAMP, which came about in the late 90s and stands for Linux, Apache, MySQL, and PHP. Building a web application in the 90s was a lot more complicated and typically required expensive commercial software. LAMP was a free and open source stack that eventually led to web frameworks like WordPress and Joomla. In modern times, building a web application is much easier, but tech stacks have become far more complicated because there's so many different companies selling shovels in the startup gold rush. That begs the question, what is a tech stack exactly? There's no official definition, but I would break it down into three parts. First, you have the front-end layer, which includes the tools required to build a user interface for the end user. On the web, that likely means a JavaScript framework, or for mobile, it might be iOS, Android, or a cross-platform tool like Flutter. At the other end, we have the back-end layer, which includes a server-side runtime like Node.js or Python, along with a database to store user-generated data. In addition, you'll likely purchase this infrastructure from a big cloud provider, and they'll try to lock you in, so I would consider them as part of your tech stack as well. Now, the third and final layer is APIs, which are the tools used to connect the front end to the back end. That might be something like REST or GraphQL that you roll out on your own, but mostly it includes essential third-party services that you absolutely need to run your app, like Stripe for payments, Twilio for text messaging, SendGrid for email, and so on. These tools often do things that fall into both the back-end and front-end categories, so we put them in the middle. Now let's take a look at some common tech stacks that you've probably heard of, starting with Mean, which stands for MongoDB, Express, Angular, and Node. The reason this stack got so popular is because it has a catchy acronym. It's important to make that acronym pop, because it will automatically make other people in the tech industry think you know what you're doing. Like on Fireship.io, I made up my own tech stack called Fancy, which stands for Firebase, Hugo, Angular, Node, Stripe, and Express. It works great, but sometimes I do regret choosing my tech stack entirely for the acronym. Others have realized this with the Mean stack, and there are variations like MERN and Maven, which use React and Vue respectively. The reality though is that these acronyms don't accurately capture everything you really need in a tech stack. If you want to see what other successful companies are using in their stacks, there's a website called stackshare.io. You can see how popular technologies are and which companies are using them. Let's go ahead and build our own from scratch. But the first time around, let's use the hottest of the hot technologies at every single point, regardless of cost or complexity. Don't worry, by the end of the video, we'll come back and simplify things in a much more practical way. Let's imagine we're building the next MySpace, an app that requires user authentication, a database to store user-generated data that needs to scale around the world. Let's start by architecting the front-end layer. The very first question you need to ask is, where will my customers be consuming the application? Is it the web, iOS, Android, desktop, IoT, or something else? For this app, we'll assume that our customers are primarily on the web, but we might also want to build a mobile app in the future. When targeting the web, the programming language in your front-end layer will almost always be JavaScript. There are tools that can help you avoid JavaScript if you really want to, but if your goal is to build a killer web app, I would highly recommend embracing JavaScript. But we need this app to scale, so we're not just going to use vanilla JavaScript, but instead TypeScript. That adds a type system on top of JavaScript, which might help us catch bugs earlier and deliver more reliable code. The next thing we need is a UI framework, because trying to build a complex UI with vanilla JavaScript is very painful. There's too many options to even analyze, but I have a video comparing 10 of them. I'm choosing React for this app, not because it's the best or the fastest, but because it's the most popular. Sadly, many decisions end up being a popularity contest. As much as I wanted to choose Svelte, I know that choosing React will will give me a much larger pool of developers to hire in the future. On top of that, I can more easily add React Native to my stack to build a mobile app. But React on its own is still not enough for our web application. We heard on the street that we'll need a state management solution if our app has any hope to scale. There are dozens of different state management libraries for React alone, but we'll choose the most popular option that everybody also hates the most, Redux. It allows us to write a lot more boilerplate code, which is awesome because we all know that more code leads to better quality apps. Now, another glaring problem with our tech stack is that it's currently using vanilla CSS. It's basically impossible to make CSS look good on its own, so we're going to bring in Tailwind. That'll give us a bunch of pre-built utility classes to style things quickly in exchange for some crazy looking HTML. We're also going to want a CSS preprocessor like Sass. Just like TypeScript, it provides some extra syntax to help us write code more efficiently. And we're also going to need PostCSS to purge any unused styles from our code base and prepare our CSS for production. Now at this point, we have almost everything we need to build the front end. The only thing we're missing is a module bundler, which takes all of our raw JavaScript files and combines them into a single bundle that can be used in the browser. There's many options to choose from, and they're notoriously frustrating to configure. I'm going with Webpack, which is the most popular option today. That'll give us almost everything we need for the front end stack. Now it's time to switch gears to the hard part, the back end. The most important decision you'll make here is the database for your user-generated data. A good option for us might be a NoSQL document database like MongoDB or Firestore. They're easy to learn, inexpensive, and can scale to practically any workload, but they sometimes struggle to model certain types of relationships, especially things like a social graph that we might want for our MySpace clone. The most popular database option out there is the relational database, like MySQL, Postgres, and many other options. These databases are great at handling relationships, but they're not quite as flexible to changing requirements and generally more expensive to operate. There's also more exotic graph database options out there, but in this demo, we'll go with the gold standard of MySQL. Now that we've chosen our database, we find an article on the web that says it's not going to be fast enough at scale. To address this, we're going to add a second database to our stack called Redis, which is often used as a cache because it stores all of your data in memory as opposed to the disk, which is much faster to read from. But in order to put these databases to work, we need a server-side runtime where we can write code to access data and then send it back to the front end. There are tons and tons of options to choose from, and often the decision comes down to the programming language that you're most comfortable with. If you like Python, there are frameworks like Flask and Django that help you build server-side web applications. There's Ruby on Rails, Laravel for PHP, Spring for Java, and so on. As a JavaScript developer, I'm going to go with Node.js as my runtime, and then use a framework called Nest to handle the server-side web application stuff, because it supports TypeScript out of the box. We also don't want to have to write raw SQL queries, so we're going to bring in an object relational mapper like TypeORM. So that gives us a runtime for writing and executing code on a server. But in order to make that server available to the world on the internet, we also need a web server like Nginx or Apache. So let's throw one of those on the stack as well. But now that we have a server framework, we need to figure out how to deploy it. Before we can do that, we need to standardize the environment for our code by containerizing it with Docker. This creates a standard Linux environment that we can then use to deploy our code to any cloud server. But as our app scales, we'll need to orchestrate multiple containers. So for that, we're going to bring in Kubernetes. Then we'll need to choose one or more cloud providers to host all this infrastructure. Let's go with Amazon Web Services to give us the most complicated user experience. Now, because we're smart, we're not going to just go on AWS and click on buttons. Instead, we'll use Terraform to programmatically create our infrastructure and version it for better reliability. Now, we also need a place to host our actual source code, and I can think of no better place than GitHub. The reason we want to host our source code in the cloud is to set up a continuous integration pipeline. We can add GitHub Actions to the stack to automatically test and redeploy our code anytime we push an update to the repository. That gives us a solid backend, but there are many things our app needs to do that are just too complicated to handle from scratch. One of those things is building an API for our front end and back end to communicate. We heard on the internet that GraphQL is awesome, so we're going to add it to the stack along with a library called Apollo, which will provide code on both our front end and back end to help us build a GraphQL API, which allows the front end to securely communicate with the back end. Another thing we're not going to want to do is deal with payments, so for that, we're going to bring in Stripe, which provides SDKs for both the server and front end to collect payments. We also don't want to deal with user authentication, so we'll bring in Auth0 to handle that. We also don't want dudes uploading dick pics to our platform, so we'll bring in Amazon Rekognition with its deep learning dick detection capabilities. We also have no idea how to send text messages to our users, so we'll bring in Twilio to help us with that. I could keep going here, but you get the idea. We use APIs to help us for the things that are too hard to do on our own. At this point, we have a nearly complete tech stack, but it's likely way more complicated than it needs to be. It's important to keep in mind that your end users don't care and will never know what technology you use to build the application. They just want to have a good experience, and if you don't build a good experience at first, you'll never get to the point where you actually need something like Kubernetes. Let's go ahead and throw this entire tech stack in the garbage and start from a plain HTML file. Now, our web app does need to be interactive, so we need some kind of JavaScript framework. Instead of something big and heavy, let's throw in a new option called Petite Vue. It has a syntax that's compatible with Vue.js, which many developers out there already know, and we can drop it in with a script tag, so we're not even going to need a module bundler like Webpack. When it comes to CSS, we'll throw in Bootstrap, which is a little more cookie cutter than something like Tailwind, but is probably the quickest way to get to a decent looking UI. If we decide we need a mobile app, we're going to bring in Ionic to wrap our application in a web view, allowing us to quickly ship it off to iOS and Android. That takes care of our front end stack. To simplify the back end, we'll bring in Firebase. It gives us a document database that can scale without any need for a back-end server. It also handles user authentication, and we can include it in the application by simply adding a script tag to the document. Now, we still might want to write some server-side code, in which case we can use Firebase Cloud Functions, which is a serverless option that allows us to write code in Node.js, or Python or Go if you prefer, and deploy it with a single command without ever having to worry about the server configuration. It scales automatically without ever having to worry about Docker, Kubernetes, or Terraform. When it comes to continuous integration, we're just not going to worry about it. Unless you find yourself testing and redeploying your app every day, it's probably just a waste of time. We can also get rid of GraphQL because it's more well suited for complex apps that have multiple APIs to stitch together. And that leaves us with the PetiteFire stack, which is quite possibly the easiest way to build a full stack web application. I'm going to go ahead and wrap things up there, but if you want to learn more about building full stack web applications with Firebase using multiple different front-end frameworks, check out Fireship Pro to get access to my full courses. Thanks for watching, and I will see you in the next one.
I will explain to you what the video is about. Let's start with historical stacks. In the past, one of the most popular stacks for web development was LAMP, Linux, Apache, MySQL, and PHP. This stack helped developers get started with web applications and served as the foundation for many websites in the late 1990s and early 2000s. Even though we have newer stacks now, LAMP is an important part of web development history. Today, some of the most popular tech stacks are Mean, MongoDB, Express, Angular, Node.js, and MRN, MongoDB, Express, React, Node.js. These stacks use JavaScript for both the front end and back end, which makes development faster and more efficient. These are widely used for building dynamic, scalable web applications. When choosing a tech stack, it's important to do your research. Platforms like Stacksair.io can help you see which stacks successful companies are using. This can give you valuable insights into what might work best for your own project. Let's move on to front-end development. For the front end, JavaScript is essential. React is one of the most popular libraries for building user interfaces. Tools like Redux help with managing the state of applications, and Tailwind CSS helps make styling websites quicker and easier. Back-end development involves working with databases and server-side technologies. For the back end, MySQL is a popular choice for databases, and Redis is often used to speed up performance with caching. Node.js is commonly used for building the server side of applications. Containerization and cloud are important for managing and deploying applications. Docker helps with packaging applications, and Kubernetes manages how they are deployed and scaled. AWS is a reliable cloud platform used for hosting and managing applications, and GitHub is used for version control. APIs and integrations are critical in modern web development. GraphQL allows you to query data efficiently, Stripe helps with payment processing, and Twilio provides messaging and communication services within applications. For beginners, it's a good idea to start simple. Begin with basic technologies like HTML before moving on to more complex tech stacks. This will give you a strong foundation before you dive into full-scale development. Finally, my recommendation for beginners is the Petit Fire stack. This is a simple yet powerful stack that combines Petit Vue for the front end and Firebase for the back end. It's a great way to start building full-stack applications without getting overwhelmed by too many tools. In conclusion, the key to choosing the right tech stack is understanding your project needs and starting with the right technologies. Whether you're just starting or building more advanced applications, there are tools and stacks that can help you get the job done efficiently. The technology stack for an order fulfillment management system involves a combination of different technologies that ensure the efficient handling of orders, inventory, shipping, and customer notifications. Below is a simplified breakdown of the key component: A. Frontend, React JavaScript, Vue JavaScript, or Angular for user interfaces. B. Backend, Node.js, Django, or Flask for order management and system integration. C. Database, PostgreSQL or MySQL for order and inventory management. D. Shipping carrier integration, REST APIs for FedEx, UPS, DHL, etc. E. Payment integration, Stripe, PayPal, or similar services for secure payment processing. And F. Cloud storage, AWS, Google Cloud, or Azure for hosting and scaling. The next slides will explain all these technology respectively. There are 3 examples of front-end development. First, React JavaScript, a widely used and flexible front-end framework, known for its strong ecosystem. It is a popular choice for building dynamic and interactive user interfaces. Second, Vue JavaScript, a lightweight framework that emphasizes simplicity and easy integration. It is perfect for quick development and responsive designs. And third, Angular, a more robust framework, suitable for building complex web applications, offering advanced features for dynamic content and data binding. These technologies are essential in creating a responsive and smooth frontend for your order fulfillment system. They allow for real-time updates, order tracking, and effective inventory management. Why front-end development is important? User interface. Front-end development creates a user interface that is responsive and interactive. This is crucial because it directly influences how users will interact with the order fulfillment system, making it intuitive and easy to navigate. Order tracking. With front-end development, users can monitor the status of their orders in real time. It ensures that customers and internal teams have up-to-date information about order progress, shipping, and more. Real-time updates. Real-time updates are crucial in keeping track of order status and inventory levels as changes occur. This enables businesses to respond to any delays or stock issues promptly. Inventory management. The front-end interfaces allow businesses to manage and track inventory in real time, ensuring stock availability and preventing overselling. These components are the backbone of a seamless order fulfillment system, enhancing both customer experience and operational efficiency. There are 3 examples of back-end development in order fulfillment management. First, Node JavaScript, ideal for real-time order processing due to its asynchronous nature. It's great for handling multiple tasks at once, which is perfect for order management systems. Second, Django, a robust framework offering strong security and ease of building web applications. It includes ready-to-use tools for authentication, database handling, and more, making it great for managing complex order fulfillment processes. And lastly, Flask, a lightweight framework, flexible for building smaller applications. It's perfect for systems that need minimalistic but efficient back-end solutions. These back-end technologies ensure secure, efficient order processing, payment integration, and shipping management. Why back-end development? Firstly, order processing. The back-end manages the entire order cycle, from placement to shipping, ensuring stock is allocated and orders are processed smoothly. Secondly, payment integration. It ensures secure connections between the system and payment gateways, making sure payments are successfully processed. Thirdly, shipping management. The backend integrates with shipping carriers to manage delivery tracking, logistics, and shipping updates. Backend development is key to handling the core operations, providing real-time data, and ensuring the system runs smoothly. There are 3 examples of database management in order fulfillment management. Firstly, PostgreSQL is a powerful, open-source relational database that can handle complex queries and large datasets. It's often used in situations where the database needs to handle complicated relationships or transactions. In addition to traditional relational database features, PostgreSQL supports JSON, XML, and key-value pairs, which allows for flexibility in handling unstructured data. PostgreSQL is preferred for high-volume, high-complexity applications where large datasets are involved or when advanced data features are required. Another one example is MySQL. MySQL is often chosen for web applications where simplicity and quick setup are more important than complex features. It's lightweight and highly reliable. If the application is focused on handling straightforward data relationships with no need for complex transactions, MySQL is a great choice. It's often used for applications that require fast performance, simple query operations, and ease of management. Why is database management important in order fulfillment systems? Firstly, order details. Storing order information like product types, quantities, pricing, and order statuses is crucial for keeping track of customer purchases and delivering them on time. A database management system makes it easy to retrieve and update order information in real time. Secondly, customer information. It's essential to store customer data, name, address, contact details, so you can offer personalized services, handle shipping details, and track customer behavior for improving the shopping experience. Thirdly, data consistency. In a dynamic order fulfillment process, it is vital that all parts of the system, inventory, shipping, payment, reflect consistent data. A reliable database ensures that changes in one area are accurately reflected throughout the system. Fourthly, high-traffic operations. The database must handle many simultaneous requests without slowing down. Especially during sales or promotions, the system needs to manage multiple orders, inventory updates, and customer queries without crashing. Fifthly, inventory levels. The database helps keep track of current stock levels, preventing overordering or underordering. It ensures that customers can only order products that are available in stock, preventing disappointments or lost sales. Next is transactions. Efficient handling of sales and returns is crucial. The database tracks these transactions securely to ensure that products are shipped, returned, or exchanged as needed. Lastly, scalability. As your business grows, so does the need to scale your database. It should be able to manage more products, customers, and transactions over time without affecting performance. Here, there are two examples of shipping carrier integration in order fulfillment management. One is shipping carriers integration. This allows the system to connect with various shipping companies like FedEx, UPS, and DHL. By integrating carrier APIs, you can automate the process of sending shipping details, creating shipping labels, and tracking shipments. Another one is API automation. Shipping APIs automate the process of interacting with the carrier's system, eliminating manual data entry and minimizing errors. The API ensures that shipping information is automatically synchronized between your order fulfillment system and the shipping provider. Why is shipping carrier integration important in order fulfillment? First, enable real-time tracking updates. Customers expect to know the status of their shipments at all times. Real-time tracking gives them visibility into where their package is, which reduces anxiety and increases satisfaction. Integration with carrier APIs makes it easy to provide automatic tracking updates to customers, without manual intervention. Second, provide multiple shipping options. Different customers have different needs. Some may prefer low-cost standard shipping, while others may need faster delivery via express services. By integrating with shipping carriers, you can provide multiple shipping options for the customer to choose from based on their preference and budget. The system can also calculate the cost of shipping automatically based on the package weight, size, and destination. And third, automate label printing and scheduling. Shipping carriers provide a system for generating shipping labels. Through API integration, your order fulfillment system can automatically generate these labels, ensuring accurate information like addresses, tracking numbers, and shipping methods. This reduces the time spent preparing shipments and the chance of errors in the labeling process. Why this integration is essential. 1. Efficiency. By automating the shipping process, you can handle a larger number of orders without increasing manual workload. 2. Customer satisfaction. Real-time updates on delivery status and the ability to choose shipping options enhance the customer experience. 3. Cost savings. By selecting the best shipping methods automatically, you ensure that your business is saving on shipping costs while still offering reliable services. There are 3 examples of payment integration. First, Stripe, a globally recognized payment processing platform that offers fast, secure transactions with built-in fraud protection. Stripe supports multiple payment methods, ensuring your business can manage payments efficiently across different channels. It's particularly ideal for handling large volumes of online transactions. Second, PayPal, one of the most widely used payment systems worldwide. PayPal allows customers to make secure payments instantly. It's known for its ease of use and widespread adoption. It also provides additional services such as refund processing. And lastly, Razorpay. This payment gateway is ideal for businesses operating in India or similar localized markets. Razorpay supports a wide range of payment methods including credit cards, debit cards, and net banking, making it suitable for small and medium-sized businesses looking for affordable solutions. These technologies enable smooth and secure payment processing, which is a key component of any order fulfillment system, ensuring that payments are quickly processed and funds are securely transferred. This section explains why payment integration is crucial for your order fulfillment system. Firstly, operational support. Payment integration helps businesses manage various operations like handling refunds, chargebacks, and processing multiple currencies. It ensures smooth transaction management, giving businesses the operational flexibility to handle complex transactions. Secondly, transaction handling. The integration allows you to manage transactions, including credit/debit card payments, e-wallets, and online banking. It ensures that the system supports a wide range of payment methods, meeting customer needs and expectations. Thirdly, financial security. Ensuring secure transactions is a top priority for any order fulfillment system. Payment gateways like Stripe and PayPal are PCI DSS compliant, meaning they follow stringent security standards to protect customers' sensitive data from unauthorized access. Payment integration systems not only support the financial aspect of the business but also safeguard against fraud, providing customers and businesses peace of mind. 3 examples of technology in cloud storage and hosting: Amazon Web Services, Google Cloud, and Azure. First, Amazon Web Services offers a comprehensive suite of cloud computing services, including storage, computing power, and networking. AWS is highly scalable, secure, and reliable, making it an ideal choice for businesses that need robust cloud hosting and computational power to run their order fulfillment systems. Second is Google Cloud. Google Cloud provides strong artificial intelligence (AI) capabilities that can be integrated into your fulfillment system. It is especially beneficial for inventory prediction and customer insights, enabling businesses to forecast needs and improve customer satisfaction. And lastly is Azure. Microsoft's Azure platform is another cloud computing option. Although not elaborated here, it's widely known for providing a comprehensive set of services and solutions for businesses of all sizes, including hosting and data security. These cloud storage platforms offer scalability and flexibility to store critical data securely, making them an essential part of an effective order fulfillment system. With these technologies, businesses can handle large volumes of data and scale their operations as needed. The importance of cloud storage and hosting for your system is outlined in these key points. 1. Disaster recovery. Cloud platforms like AWS, Google Cloud, and Azure offer robust disaster recovery options. In case of any disruptions or disasters, these platforms provide solutions to restore the data quickly, minimizing downtime and loss. 2. Backup options. Cloud services ensure that your data is backed up regularly, helping you recover from unexpected issues. It also provides redundancy to ensure data is never permanently lost. 3. High availability. With cloud hosting, your system can be accessed at all times, ensuring that the data and services are always available, even during peak demand periods. Cloud systems are designed to handle multiple requests concurrently without performance degradation. Next is data security. Protecting sensitive customer data and order information is critical. Cloud platforms implement high levels of security, using encryption and other security measures to safeguard data from unauthorized access. And the last one is auto-scaling. Cloud hosting can automatically adjust resources to meet demand. As order volumes increase or fluctuate, the system can scale up or down without manual intervention, ensuring smooth operations. These cloud-based features help maintain an efficient and secure order fulfillment system, providing the infrastructure needed to handle complex data management tasks and ensuring that your system is always available to your customers. In summary, an effective order fulfillment management system relies on a robust combination of technologies across front-end, back-end, database, payment integration, shipping carrier integration, and cloud storage. These technologies, such as React.js, Vue.js, Angular for front-end development, and Node.js, Django, or Flask for back-end development, ensure that the system operates efficiently. PostgreSQL and MySQL serve as the backbone for data management, handling complex queries and ensuring data consistency. Payment systems like Stripe, PayPal, and Razorpay facilitate secure transactions, while shipping carrier integrations such as REST APIs for FedEx, UPS, and DHL streamline logistics operations. Cloud storage platforms like AWS, Google Cloud, and Azure ensure data is safely stored and available at all times, with scalable infrastructure to handle increasing demands. Using this comprehensive technology stack guarantees a seamless, scalable, and efficient order fulfillment system, resulting in improved customer satisfaction, accurate inventory management, timely order processing, and smooth payment and shipping workflows. These technologies work together to support the business operations and contribute to a streamlined and user-friendly order fulfillment experience.